Hello friends and my dear students, I welcome you all to my channel. If you are new to my channel or not yet subscribed, I will highly request and suggest that you subscribe to my channel and also do not forget to press the bell icon so that you will be notified by my future videos. So this video is part of the playlist CBSE Mathematics class 7 following the textbook of author R.S. Aggarwal. This is class number 4 on the chapter Algebraic expressions. In this class I will discuss about the multiplication of monomials, and the key concepts will be how we do product of variables using laws of exponents. Exponents I have already discussed, it was the previous chapter. If you have not watched exponents, I highly suggest you watch my videos on the chapter exponents. Then we will see how we evaluate a product of monomials by substitution of variables with given values. And then we will solve some problems from exercise 6a. Even though exercise 6a is based on addition and subtraction of algebraic expressions, just for the sake of completeness, I will solve few problems from 6a, and will solve few problems from exercise 6b, which is based on multiplication of algebraic expressions. So in this video I will only discuss multiplication of monomials. So let's get started. Okay, as usual I have my notes on the left hand side, and I will discuss and solve the problems on the right hand side. Now so multiplication of algebraic expressions, there are three kinds of multiplications. As you know, in this class you will learn multiplication of monomials. Now what are monomials? Monomials are algebraic expressions that has only a single term. And multiplication of a monomial and a binomial. Binomial is a algebraic expression where we have two unlike terms. And then finally multiplication of two binomials. In this video I will discuss only multiplication of monomials. Now to understand how we do multiplication of monomials, we need to first understand how we do product of factors. Now monomials, since monomial is a single term algebraic expression, you can also consider a monomial as a term. So basically we have to learn how do we find product of two terms. Now so there are some rules that are written down which need to be followed while doing the product of two terms. So rule number 1 is that if the sign of product of two terms have similar sign, the terms, if you are the terms that you are finding the product of, if they have the same sign, meaning they are both either positive or both negative. For example, by sign I mean, let's say these two terms minus x and xy, they are of opposite sign. The first term is negative and the second term is positive. So when you find the product, the product will be negative. The product will be negative. And if you if you do product of two terms having the same sign, like y square x and xy, or let's say minus y x and minus z cube, whatever, if the two terms are negative or positive, that is they both have same sign, then the product will have a positive sign. The product term will be positive. This thing you have to keep in mind. And the actual product, okay, one more thing, before rule 2 we need to understand rule 3. Now if x is a literal, so basically you know that in a term is nothing but product of a constant and few literals, and some literals may appear more than once. For example, in the term minus 4x y square by z cube, this is a term. So here we see it's a product of minus 4, that is the constant part, multiplied by the literal x, and the literal y is multiplied twice, and then the whole we have divided by the product of z, literal z, 3 times. This is the basic structure. Now, when so if you multiply a literal, so x, y, z are literal, that is they are literal variables. So if x is a literal variable and m and n are positive integers, then we have, if you need to multiply, if you need to do a product of, let's say, so x to the power m multiplied by x to the power n equals to x to the power m plus n. This is a very this is the laws of exponents that you have already learned in the previous chapter. Over there we did exponents based on numbers like integers, rational numbers, or whole numbers, whatever. But over here we have to also deal with variables, that is the literal variables x, y, z, and they work the same way. So if we need to multiply x cube multiplied by x square, this will be nothing but x. We just add up the powers. 3 plus 2 is 5. So this thing we have to keep in mind. This thing, okay. And then how we do actually the multiplication of two terms. So let's say if T1 and T2 are two terms, please follow the notes on the left hand side. If T1 and T2 are two terms where T1 is of the form K1 into L1, where K1 is the coefficient, or coefficient means the numerical coefficient of the term T1, and L1 is the literal coefficient. For example, this is nothing but, let's say, if the term T is minus 4xy square z, let's say, for this term the constant K1 is nothing but the coefficient of the term, that is the numerical coefficient, this thing minus 4, and L1 is nothing but everything in the term except the coefficient, that is x y square. This is what I meant to say by L1 and K1. So let's say, so if T1 is K1 L1 and T2 is K2 L2, so T1 and T2 are two terms. So then the product of T1 and T2, then the product of T1 and T2 is nothing but you multiply the both the coefficients of the two terms, and then you multiply the the literal coefficients of the two terms. So it is K1 into K2, L1 into L2. Now the K1 and K2 becomes the coefficient of the product, that is T1 and T2. The coefficient of T1 and T2, whenever I say coefficient of term, it also means the numerical coefficient of the term. So coefficient of T1 and T2 becomes K1 into K2, and its literal coefficient, the literal coefficient of T1 and T2 becomes L1 into L2. Okay, so you can see, for example, in the notes you can see T1 is 4x and T2 is minus 5xy. So for T1, the K1, the constant, the coefficient is 4 and the literal coefficient is x. For T2, the coefficient is minus 5 and the literal coefficient is xy. So when we do product of T1 and T2, it is nothing but we first find the coefficient, that is the K1 into K2, and then we multiply the literal coefficient, that is L1 into L2. Now K1 and K2 is fine, it is 4 into multiplied by minus 5, but L1 is x and L2 is x into y. So when you are doing x multiplied by x into y, you have to merge all the same literals in the exponential form. So we have x into x and y. So we have 2x, x multiplied by x, so that will become x square, and y will remain the same. So the answer is minus 20x squared. This is how we do the product of two terms. Another example you can see, I will not explain in the notes. You can take a screenshot. If you wish, you can take a screenshot of the rules. You can pause the video and take screenshot for your future reference. Okay, so this was how we do product of two terms. Now since we are discussing product of two monomials, and monomials is nothing but a single term, an algebraic expression with a single term. So we are talking also when we are talking product of two monomials, it also means product of two terms. Okay, let's see what else is there. Okay, this is it. That is it for the theory part of the product of two monomials. You just rule 3 is important, that whenever you find, you have to keep in mind the law of exponents, that is x to the power m multiplied by x to the power n, where m and n are positive integers, equals to x to the power m plus n. This is one concept you need to keep in mind. And the rule 2, that is whenever you are finding the product of two terms, the coefficient of the product will be the product of the coefficients of the two terms, and the literal coefficient of the product will be the product of the literal coefficients of T1 and T2, the two terms. Okay, so I think now we are ready to solve some problems. So let's solve some. I hope you can see the. I've noted down all the problems that I will solve. Okay, these are the problems I need to solve. Okay, so let's solve the problems. For the sake of completeness, I will solve a few problems from exercise 6A. So exercise 6A, it says add the following terms. Okay, 1 7 1 7, add the following expressions. So the first one is 5x minus 2x square minus x minus 8, then 8x square minus 7x minus 9, and then 3 plus 7x square minus 2x. Okay, so we are given 3 algebraic expressions and we have to add them. So basically we have to find 5x minus 2x square minus 8 plus 8x square minus 7x minus 9 plus 3 plus 7x square minus 2x. So first we will add the like terms. We will add the like terms and we will leave the unlike terms unchanged. So we see that there are the like terms. We see that the like terms we have. Let's first group the like terms which has the common literal coefficient of x square. So this becomes, if I collect all the like terms with the literal coefficient of x square, this becomes minus 2x square from the first expression, then plus 8x square from the second expression, then plus 7x square from the third expression. Okay, now let's collect the add the like terms where the literal coefficient is x. So from the first expression I get 5x, from the second expression I get minus 7x, and from the third expression I get minus 2x. Similarly, we collect all the constant terms from all the expressions and we get minus 8, minus 9 and plus 3. So now if we add the like terms, we get minus 2 plus 8 plus 7 x square plus 5 minus 7 minus 2 x, and this is minus 17, that is minus 14. Minus 17 plus 3 is minus 14. Now this becomes 15 minus 2, that is 13 x square, and this is minus 9, 5 minus 9, that is minus 4. So minus 4x, and this is minus 14. So this is the result of adding the 3 given algebraic expressions. Okay, let's see. While I am solving it, you can pause the video and take a screenshot if you wish for your reference. Let's do question number 1, part 9. This is 8 by 5x plus 11 by 5y plus 9 by 4 xy, comma minus 3 by 2x minus 5 by 3y minus 9 by 5xy. So we are given two algebraic expressions and we have to add them. So we have to add, this is the first algebraic expression, 9 by 4xy, and we have to add the second algebraic expression, which is minus 3x by 2 minus 5y by 3 minus 9 by 5xy. So we collect all the, let's first collect all the like terms with the common literal coefficient of x. So this becomes, from the first term we get 8 by 5x, from the second term we get minus 3x by 2. And let's collect the like terms with the literal coefficient of y. So from first expression we get 11 by 5, 11y by 5, and from the second expression we get minus 5 by 3 y. Now let's collect the like terms having the literal coefficient xy. So from first term, first expression we get 9 by 4 xy, and from the second expression we get 9 by 5 xy. Okay. So now we have to simplify, add the like terms. We get 8 by 5 minus 3 by 2 x, and this becomes 11 by 5 minus 5 by 3 y, and this becomes 9 by 4 minus 9 by 5 x y. Now you have to find the difference of all these rational numbers. Let's quickly do it. This will be 5 and 2, the LCM of 5 and 2 is 10. So this will be 16 by 16 minus 15, and this is 10 x plus, and this will be 33 minus 25 by 15 y, y plus, this will be 45 minus 36 20 xy, and this is x by 10 plus, how much is this, 8 by 15 y, and plus 9 xy by 20. So this is the sum of the two given algebraic expressions. Let's do the part 3. This is an easier one. So we have to add these three expressions, where each expression is a monomial, we can see, and clearly they are like terms. So we have to find 5a square b minus, now remember that these are the algebraic expressions. So when we do addition, I hope this is clear to you, we are actually doing plus minus 8a square b plus 7a square b. Now this is equals to, since all the terms are like terms having the literal coefficient of a square b, we can add the like terms as we have discussed in previous video while solving the 10 MCQ. If you have not watched the previous video where I solved 10 MCQ, just to refresh your concepts from class 6, that is addition of like terms, subtraction of like terms, and addition and subtraction of algebraic expressions, I highly suggest that you please watch the previous video. Okay, so how do we do add like terms? We add the coefficient. We add the coefficient. So this will be minus 8 plus 7, and we have the literal coefficient. So this becomes 4 a square b. So this is the result, answer. Okay, let's solve question number 3. This is also from exercise 6a. Subtract this algebraic expression from the sum of given three algebraic expressions. Okay. So let's first, so if we say let A equals to 2A minus 3B plus 4C, this we have to subtract from the sum. Let's say the sum equals to A plus 3B minus 4C. We have to find the sum of the given three algebraic expressions. So let the sum be S. We have to find this first, and then we will subtract A from S. Now to find S, we have the sum of three algebraic expressions. We will collect the like terms. So let's first collect the terms with literal coefficient A, and this is 1 plus 4A minus A. Then let's collect the like terms with literal coefficient B. So this is 3B minus B minus 2B, and let's collect the like terms with literal coefficient C. We have minus 4C plus 9C plus 3C. So now if we add up the like terms, all the like terms, we get 1, oh, okay, fine, 1 plus 4 minus 1, A, plus 3 minus 1 minus 2, B, plus minus 4 plus 9 plus 3. We are just adding for adding the like terms, we add up the coefficients. So this becomes 4A, and so B is gone. B is, we can see, is gone. 3 minus 3 is 0. So B is gone. There is no B. Okay. And C is, what is C? Minus 1. C is 8. C is 8C. 12. Okay. So this is S. Now we have to find S minus, we have to subtract A from S. We have to now, from S we have to subtract A. So this is 4A plus 8C minus 2A minus 3B plus 4C. So this is, now in the previous video, while solving the 10 MCQs, I discussed how do you, so now this is, so now S minus A, so whenever, so you can see this is 4A plus 8C, we can open the grouping. So we have grouped the algebraic expressions. So when we open the grouping of 4A plus 8C, we can open it because before it we have plus. The first term is always positive. The first, S minus A, S is assumed to be positive. So we can, without any changes, we can open the grouping of 4A plus 8C. Now the second expression, algebraic expression 2A minus 3B plus 4C, it is grouped, it is inside a group, but before the group we see a negative sign. And so to open the group, we have to negate all its terms. So this becomes plus the, actually it will be minus 2A, we have to negate all the terms, plus 3B and minus 4C. Now you can open the grouping. I hope this is clear. This is very essential for you to understand for doing simplification. If instead of minus it was plus, then we could have opened the groupings without any problem for the second algebraic expression. But since in this problem we are doing S minus A, so minus A, to find minus A, we have to negate, we have to change the sign, all the sign of the terms of A, and then we will add those terms after change of sign with S. So this is this. Now we have, see, we will again collect the like terms, and we get 4A minus 2A, 3B remains the same because it is only the single like term, and for the C we have 8C minus 4C. Okay, so this becomes 4 minus 2A plus 3B. This becomes 8 minus 4C. So this is 2A plus 3B plus 4C. So this is the result. Okay. We are still doing exercise 6A. Let's do question number 4, simplification problem. Let's do part 2. Okay. It is, part 2 is x square minus x, this is an algebraic expression, minus half x minus 3 plus 3x square. Now this half, this is equals to x square minus x. Now this minus half, you see minus half, actually this is half, the product of half and this algebraic expressions. Now you can multiply the half with all the terms inside. So I can say this is nothing but actually x by 2 minus 3 by 2. I am multiplying half with all the terms inside. This is 3 by 2 x square. So now we see the second expression is inside a group, and before that group there is a negative sign. So we have to, if we want to open the group, we can, for the first expression we can simply open the group because before it there is plus only. And for to open the grouping of the second group, we have to change the sign of all its term. So this becomes, instead of negative, instead of the minus sign, we will put plus and we will negate all the sign of its terms. So x by 2 becomes minus x by 2, minus 3 by 2 becomes plus 3 by 2, and 3 by 2 becomes 3 by 2 x square becomes 3 by 2 minus 3 by 2 x square. Now we can remove the grouping, and we can simply say this is minus x by 2 plus 3 by 2 and minus 3 by 2 x square. So now we have to collect all the like terms. So if we collect the like terms with the literal coefficient x square, we get x square minus 3 by 2 x square, and if we collect the like terms with the literal coefficient x, we get minus x by 2, and we are left with the constant term 3 by 2. So now if we do the addition of the like terms, we get 1 minus 3 by 2 x square plus minus 1 minus half x plus 3 by 2. This is minus half x square, and this is minus 3 by 2 x, and this is plus 3 by 2. So this is the result of the simplification. Okay. While I am solving it, you can pause the video and take a screenshot. Okay. Let's do part 3. This is 7 minus 2x plus 5y minus x minus y is in a group, and then another group, and then finally we have a minus 5x plus 3y minus 5. So this is a simplification problem. For to evaluate the first expression, that is in the square bracket, we have to first evaluate its inner grouping, that is x minus y. So 7 minus 2x plus 5y. Now we have to open the grouping of x minus y, and we see that before that there is a negative sign. So it's we have to change all the signs of the terms. The terms of x minus y are x and minus y, so we will change its sign. So it will become, x will become minus x, and the minus y will become plus y. So we have opened the inner grouping. Now the last expression we also need to do the same thing, since there is a negative sign in front of the grouping. So 5x will become minus 5x, so it becomes minus 5x. 3y will become minus 3y, and minus 7 will become plus 7. Okay. Now we are left with only one grouping, and we can open it without any problem because there is no negative sign before the first grouping. So it just opens up 7 minus 2x plus 5y minus x plus y minus 5x minus 3y plus 7, and now we have to simplify this, collect all the like terms, add the like terms, and leave the unlike terms unchanged. So let's collect the like terms with the literal coefficient x, and we get minus 2x minus x minus x minus 5x. Now let's collect the like terms with the literal coefficient y. So we have 5y plus y minus 3y. Now we can collect all the constant terms, that is 7 plus 7. So this becomes, now if we simplify the addition of the like terms, it becomes minus 2 minus 1 minus 5 into x plus 5 plus 1 minus 3 into y, and this is 7 plus 7 is 14. Now this becomes minus 3 minus 8x plus 4 y, 4 minus 3 is 1, so y plus 14. So this is the result. Okay, let's do part 4. This is 1/3 1 by 3 y square minus 4 by 7 y plus 5 minus 2 by 7 y minus 2 by 3 y square plus 2, and minus 1 by 7 y minus 3 plus 2 y square. So we have three expressions here. Now we can open the first grouping without any problem because there is no negative sign in front of it. So this just opens up 1 by 3 y square minus 4 by 7 y plus 5. Now the second grouping, we have a negative sign in front of it, so we will, all its terms we will open it, but all its terms will change their sign. So 2 by 7 y will become minus 2 by 7 y, so this is minus 2 by 7 y. Minus 2 by 3 y square will become plus 2 by 3 y square, so this becomes plus 2 by 3 y square. Plus 2 will become minus 2, so minus 2. Similarly, the last grouping also has a negative sign in front of it, so we will change the sign of all its terms inside. So this will become, the 1 by 7 by y will become minus 1 by 7, will become minus 1 by 7 y, minus 3 will become plus 3, 2 y square will become minus 2 y square. So now we have to, in this expression, we have to collect the like terms. Let's collect the terms, like terms with literal coefficient y square, and that is 1 by 3 y square plus 2 by 3 y square minus 2 y square. Now let's collect the like terms with literal coefficient y. So that is minus 4 by 7 y minus 2 by 7 y and minus 1 by 7 y. And let's finally collect the constant terms, that is 5 minus 2 plus 3. Now we will simplify the addition of the like terms, and this becomes 1 by 3 plus 2 by 3 minus 2 y square, and this is minus 4 by 7 minus 2 by 7 minus 1 by 7 y, and the constant part is 5 minus 2 plus 3, which is 6. Now this becomes 1 plus 2 minus 6 divided by 3 y square, plus this becomes minus 4 minus 2 minus 1 divided by 7 y plus 6. Now this is 3 minus 3, 3 minus 6 is minus 3 divided by 3, that is minus 1. So minus y square, and minus 4 minus 2 minus 1 is minus 7, so minus 7 divided by 7 is minus 1, so this is minus y, and this is 6. This is the answer. Okay. Now let's go to exercise 6b. Okay. So now exercise 6b. 6. So we have to find the product of the given terms. Now, so the first one is minus 3 by 4 a b cube multiplied by minus 2 by 3 a square b to the power 4. So we first multiply the coefficient part. The coefficient of the first term is minus 3 by 4 and the coefficient of the second term is minus 2 by 3. So we do minus 3 by 4 multiplied by minus, actually this will be, is a better way for better readability, minus 2 by 3. So this is the constant part, the coefficient of the final product, that is the product of the two coefficients, and then we will find the product of the two literal coefficients. The literal coefficients of the first term is a b cube, and the literal coefficient of the second term is a square b to the power 4. Now if you do the multiplication of the constant part, this becomes minus minus cancels, and this becomes half. This is half. And now you see, from the, when we do the product of the literal coefficients, we will merge together all the like terms, like similar literals as exponential. So we see a multiplied by a square, and then we have b cube multiplied by b4. So this is finally becomes half. A multiplied by a square, we just add the powers, 1 plus 2 is 3, so this is a cube, and b cube plus b to the power 4, we add the powers, that is 4 plus 3 is 7, so this is b to the power 7. So this is the answer. Okay, let's do 11. This is minus 7 by 5 x square y. We have three terms, 3 by 2 x y square multiplied by, the concept is same. The concept is same for two terms, the product of terms. The concept of product of terms works the same for 2 terms or 3 terms or 4 terms. We multiply all the coefficients of the terms, and then we multiply all the literal coefficients of the terms. So we have 3 terms here. If we, so the coefficient of the final coefficient of the product will be the product of all the coefficients. So let's find the product of all the coefficients. The coefficient of the first term is minus 7 by 5, the coefficient of the second term is 3 by 2, and the coefficient of the third term is minus 6 by 5. So this becomes this will be the coefficient of the final product. Now we have to multiply, find the product of the literal coefficients of all the terms. So this is from the literal coefficient of the first term is x square y, the literal coefficient of the second term is xy square, and the literal coefficient of the third term is x cube y cube. So if we do the simplification of the multiplication of the coefficients, it becomes it becomes 2 gets cancelled with 3, and this is 9 and minus minus gets cancelled, so 63. This is 63, 9 into 7, 63 by 25. So this is the final coefficient of the product. Now from the product of the literal coefficients, you see we will merge the similar literals as exponents. So we will collect the product of the similar literals, and that will become give us the literal in exponential form. So we collect all the literals with x, that is x square multiplied by x multiplied by x cube. Then we collect the y multiplied by y square multiplied by y cube. So now this becomes 63 by 25, x square into x cube. We just multiply the laws of exponents. The laws of exponents, you know that x to the power m plus into x to the power n is x to the power m plus n. But as a side note, we know that as per the laws of exponents, if x is a variable and m and n are integers, then we know that this holds. X to the power m multiplied by x to the power n equals to x to the power m plus n. But this holds for any number of such products, like x to the power m multiplied by x to the power n multiplied by x to the power p is nothing but x to the power m plus n plus p, and this can be for any number of products. I hope you got the idea. So x square into x cube becomes, we add up the powers, that is 2 plus 1 plus 3, that is 6. Similarly for y, we add up the powers, is order 6. So this is the answer. Okay, let's do 16. 16 is ab square multiplied by minus b square c multiplied by minus a square c cube and multiplied by minus 3abc. So we have here 4 terms. No problem. We will first find the product of all the coefficients of all the terms. So first we need to find the product of the coefficients of all the terms. So the coefficient of the first term is 1. The first term is ab square, so its coefficient is 1. Okay, 1 multiplied by the coefficient of the second term, which is minus b square c, is minus 1. Okay, so minus 1. The coefficient of the term minus a square c cube is minus 1. Minus 1 product, and the coefficient of the last term minus 3abc is minus 3. So minus 3. This becomes the coefficient of the final product. Now we will find the product of the literal coefficients of all the terms. The literal coefficient of the first term is ab square. The literal coefficient of the second term is b square c. The literal coefficient of the third term is a square c cube, and the last term is a b c. Okay. Now this becomes 1 into minus 1 into minus 1 into minus 3. So it will be minus 3. Okay. And now for the product of the literal coefficients, we will collect all the similar literals as exponents. So we have first collect the a. We have a multiplied by a square multiplied by a. Then we collect the b square multiplied by b square multiplied by b. Then we collect the c multiplied by c cube multiplied by c. Okay. So this finally becomes minus 3 a into a square into a, we add up the powers, that is 1 plus 2 plus 1, that is 4. So a to the power 4. Similarly for b, we add up the powers, 2 plus 2 plus 1, that is 5. So b to the power 5. And finally for c, we add up the powers, 1 plus 3 plus 1, that is 5. So c to the power 5. So this is the final product. Okay. Let's do question number 21. It says, find the value of the product of two terms are given. Find the value of this for given value of the variables u and v. Okay. So first let's find the product of the two terms 8u square v to the power 6 multiplied by minus 20 uv. Okay. We first multiply the coefficients, and that is minus 8 multiplied by minus 20. This becomes the coefficient of the final product, and then we find the product of the literal coefficients. The literal coefficients of the first term is u square v to the power 6, and the second one is u v. Now the product of the coefficients becomes 160, and for the product of the literal coefficients, we collect the similar literals as exponents. So this becomes u square into u, and then v to the power 6 multiplied by v. Now this becomes 160 u cube v to the power 7. Now this is, now we have to substitute the value of u and v which are given. This becomes u is 2.5 cube and v is given 1 to the power 7. So this is 160 2.5 cube. What is 2.5 cube? 2.5 square is 25 square. 25 into 25 is, I guess, 625. So 2.5 multiplied by 2.5 will definitely be 2.5, and again we have to do 2.5. How much is this? Anyway, I'm not doing this calculation. You can do it. So this is nothing but 160 multiplied by 2.5 cube. Please do the calculation. I'm sorry, I will not do the calculation. This will be the result. Okay. What else is there? Oh, this was it. So I hope that this set of problems will give you a good practice. These are problems from the textbook of author R.S. Aggarwal only, and I hope you have understood how we are multiplying, how we are applying the laws of exponents on the literals, that is x to the power m multiplied by x to the power n, and how we are finding the product of the literal coefficients, and finally how we are finding the product of two terms. So this was the multiplication of monomials, and monomials is nothing but an algebraic expression with one term. So in the next video I will do a multiplication of a monomial and a binomial. I hope this video was beneficial to you. If it was, then please share it, like it, share it with your friends, and also once again please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So until the next video, take care and bye.